Consider this equation of pair of straight lines x square plus 6y square minus 5xy minus 7x plus 18y plus 12 is equal to 0. We have equations of component lines x minus 2y minus 4 is equal to 0 and x minus 3y minus 3 is equal to 0. Now we consider pair of straight lines parallel to given pair of straight lines but passing through origin. Now for this pair of straight lines, we have equations of component lines as x minus 2y is equal to 0 and x minus 3y is equal to 0. This line is parallel to this line and this line is parallel to this line. Okay. Now we multiply these two equations. We get equation of new pair of straight lines passing through origin. Equation is x square plus 6y square minus 5xy is equal to 0. अब आप इन दोनों इक्वेशंस को कंपेयर करें. Compare these two equations. What do we find? क्या observation point है? The homogeneous part of this equation is same as this expression. ठीक है? That means if we consider this expression is equal to 0, then it is equation of pair of straight lines passing through origin and parallel to given pair of straight lines. अगर हम इस होमोजीनियस पार्ट को 0 लेके एक इक्वेशन बनाते हैं तो वो पेयर ऑफ स्ट्रेट लाइंस का इक्वेशन होगा जो ओरिजिन से पास होगा और गिवन पेयर ऑफ स्ट्रेट लाइंस को पैरेलल होगा. ठीक है ना. अब हम इसको जनरलाइज करते हैं. वी हैव हियर स्टैंडर्ड इक्वेशन ऑफ पेयर ऑफ स्ट्रेट लाइंस. ओके. Suppose equations of component lines are y minus m1x minus c1 is equal to 0 and y minus m2x minus c2 is equal to 0. Now if we consider this expression and compare it to 0, we have this equation. Now this is equation of pair of straight lines parallel to this pair of straight lines but passing through origin. Then component lines will be, equations of component lines will be y minus m1x is equal to 0 and y minus m2x is equal to 0. ठीक है. इस इक्वेशन के कंपोनेंट लाइंस के इक्वेशंस क्या होंगे? y minus m1x is equal to 0 and y minus m2x is equal to 0. ठीक है ना. These two lines are passing through origin. That means if we want to find the angle between this pair of straight lines, it is same as finding angle between this pair of straight lines. Now here y is equal to m1x and y is equal to m2x are roots of this equation. If we consider this equation as a quadratic in y, then its roots will be m1x and m2x. Or we can do this way. We divide this equation by x square. We get equation as quadratic in y upon x. We have equation b multiplied by y upon x whole square plus 2h multiplied by y upon x plus a is equal to 0. Now this is quadratic equation in variable y upon x. This equation has two roots m1 and m2. From this equation we have y upon x is equal to m1 and from this equation we have y upon x is equal to m2. तो इस इक्वेशन के रूट्स क्या हो जाएंगे? इक्वेशन हैज रूट्स m1 and m2, स्लोप्स ऑफ टू कंपोनेंट लाइंस. ठीक है ना. दिस हेल्प्स टू फाइंड एंगल बिटवीन पेयर ऑफ स्ट्रेट लाइंस. ओके. नाउ वी फर्स्ट गेट रिलेशंस फॉर m1 and m2. वी हैव सम ऑफ रूट्स m1 plus m2 is equal to minus 2h upon b and product of roots m1 m2 is equal to a upon b. Most important relations. बहुत सारे equations में काम आता है. We can derive many results using these two results. Okay. Now angle between this pair of straight lines is same as angle between this pair of straight lines. Here angle is theta. Then we have tan theta is equal to modulus of m1 minus m2 upon 1 plus m1 m2. Okay. So we have here root m1 plus m2 whole square minus 4m1 m2, okay, upon modulus of 1 plus m1 m2. Now in this we put the values of m1 plus m2 and m1 m2, okay. We get root 4h square upon b square minus 4a upon b divided by modulus of 1 plus a upon b, okay. So we get finally 2 root h square minus ab upon modulus of a plus b. This is equal to tan theta. So angle theta between pair of straight lines is given by this formula, 2 root h square minus ab upon modulus of a plus b. This is equal to tan theta. This is for angle between pair of straight lines whose equation is either this or this, ठीक है ना? Here we have formula in the form of coefficients of second degree terms. Second degree terms के coefficients क्या हैं? A, B and H. उसी के form में ये formula आ रहा है, ठीक है ना? Now if two component straight lines are parallel, we have angle theta is equal to 0, tan 0 is 0, so we get h square is equal to AB. जब दो component straight lines parallel होंगे तो उसके लिए condition क्या होगा? Condition होगा h square is equal to AB, जो हम पहले देख चुके हैं previous video में, ठीक है? And when two straight lines are perpendicular, tan theta approaches to infinity. In that case we have denominator is equal to 0, that means a plus b is equal to 0. जब दो component straight lines perpendicular होंगे तो उसके लिए condition होगा a plus b is equal to 0. A is coefficient of x square, b is coefficient of y square. Sum of coefficients of x square and y square is 0. This is most important condition, okay, for component straight lines to be perpendicular. A plus b is equal to 0. याद रखना, बहुत सारे questions में ये use होता है. Now let's try some questions based on these concepts.